Okay, let's try example 2 together. You should try this one before I explain it. Example 2 is also going to be a Pythagorean theorem problem. We'll be using the same process as the last ones. So it's asking us for the height of the triangle. So let's make an answer key for the height. So we're looking for h. Now, what do we have? We have an equilateral triangle, 10, 10, 10. So we know this is equilateral. But we also have a right triangle here. So let's highlight here. If I were to look at this like it's 3 triangles, I have the big triangle, the equilateral triangle. Sorry, let me say that again. We have the big triangle, which is equilateral. We have this small one on the left, and then we have this smaller one on the right. So I'm going to take this one on the right and redraw it, which, by the way, it's on the right. It is also a right triangle. And then let's bring over everything that we need. We have h here. We know that this is 10. And if I put 10 on the bottom, that is incorrect because the entire side is 10, and these congruent marks show that these two are congruent halves, which means this is 5 and this is 5. So I have a right triangle and I have side lengths. This is definitely a Pythagorean theorem problem. So let's write a squared plus b squared equals c squared and get that set up for substitution. Then let's decide which side is a, b, and c. So shine your flashlight. This is c. And between a and b, we don't know. Maybe h is smaller than 5, so let's just guess for now. Remember, guessing between A and B is fine. It is not okay to guess which side is C. A is 5, B is H, and C is 10. So let's look at where the variable bit is. It is not by itself. So we need to subtract 5 squared from both sides. And we get h squared is equal to, okay, I better not be seeing anyone do 10 minus 5. This is not 10 minus 5. It's 10 squared minus 5 squared. So let's 10 squared minus 5 squared, 75. 75 is not my answer. 75 would not make sense because the hypotenuse is 10. H has to be smaller than 10 so that the hypotenuse can remain the largest side. I need to take the radical of both sides of the equation. We're left with h. Radical 75, let's break that down. I always think of quarters. We have 3 quarters, 3 times 25, and 25 is 5 times 5. So altogether that would be 5 on the outside, 3 on the inside, 5 radical 3 is our answer. Okay, example 3. I want you to see if you can figure out how to draw the triangle on this one on your own. So what are we trying to find? Find the length of AB using the distance formula. We don't really have to, oh, I'm sorry, without using the distance formula. Don't worry if you don't know what the distance formula is because it says right there, don't use the distance formula. So we are looking for AB. We need to know how far it is from here to here. So now I want to ask you, why can't I just count? Can't you just count how far away it is? Well, the reason you can't is because, look, it's diagonal, so we can't count diagonally. But what we can do on a graph is we can count vertically, we can count up and down, and we can count horizontally, we can count left and right. So what if instead I drew a path where I could only travel vertically and horizontally? I want you to think of this trick that you often have to do when we're graphing. Instead of moving diagonally, let's move vertically. So I'm going to travel down. And then I need to travel to the right. Okay, so I can count these, right? How far did I go from, how far is that? Well, you just count, that's 4. And then how many squares did I have to move to get to B? 6. Okay, so I know that I went down 4 and then right 6. Well, wait a second. If this is perfectly vertical and this is perfectly horizontal, doesn't that mean they're perpendicular? And doesn't that mean we have a 90-degree angle here? Can you see what's missing? All we're missing is just one connected line. And now we have a right triangle. So maybe I want to redraw this outside of the graph so that it's easier for me to see. That looks kind of like it, maybe like that. Okay, so let's put the right angle where it goes here. We counted that this side was 4, we counted that this side was 6, and we're looking for this side right here, which is called AB. Okay, this looks like we have a right triangle and we're looking for a side length. So I think Pythagorean theorem is the correct choice here. Let's set this up for substitution. And which side is C? It looks like AB is the hypotenuse. And then the smallest side is 4, and the second smallest side is 6. So we get 4 squared plus 6 squared is equal to AB squared. Okay, remember this is not A times B. This is actually one variable. It's just in this case, when we're graphing, we usually name distances with 2 letters instead of 1. So this is, think of AB squared the same as if you were to see something like this. It means this same thing. And 4 squared plus 6 squared we can determine on the calculator. 52. Okay, I'm just keeping this in parentheses so that I don't forget that it's not one variable, or excuse me, so I don't forget that it is one variable. Okay, and I need to take the radical of both sides. Let me check. Does 52 have a perfect square root? Oh, it doesn't. So just remember you want to check, because if you got a whole number here, guess what? You're done. We do need to break down radical 52 though. I'm going to divide by 2. 26. So we get 2 and 26. Oops, that is not a prime. I meant to circle this one. 26 is 2 and 13. Those are both prime numbers. So 2 and 2 are a pair, and 13 is a single. So that stays on the inside, and 2 radical 13 is the length of AB.